In general chemistry, we look at oxidation as the loss of an electron, thus creating a positive charge. For covalent bonds, we see it as an increase in oxidation state. Oxidation states, or numbers, are the hypothetical charges that would occur if the molecule was 100% ionic. In organic chemistry, it can be difficult to keep track of oxidation states in complex molecules, so we follow a couple of rules. Reduction of a carbon atom occurs when a carbon-hydrogen bond is formed, or when a bond is broken between carbon and a more electronegative atom. Oxidation, by contrast, occurs when a carbon-hydrogen bond is broken, or when a bond between carbon and a more electronegative atom is formed. One important type of organic reaction is the oxidation of alcohols. In this reaction, no carbon-carbon bonds are broken, so we're only dealing with carbon-hydrogen and carbon-oxygen bonds. Tertiary alcohols cannot be further oxidized without breaking carbon-carbon bonds, so we will not be dealing with them in this video. Oxidation of secondary alcohols occurs in the presence of an oxidizing agent such as potassium dichromate and sulfuric acid, or pyridinium chlorochromate, also known as PCC, and methylene chloride. The oxidation forms a ketone, and we see the oxidation occurred because an additional bond was formed between the carbon and the oxygen. For example, this reaction shows the oxidation of isopropyl alcohol to acetone. Now let's look at primary alcohols. Primary alcohols can undergo two oxidation steps. The first step oxidizes the alcohol to an aldehyde. For example, the oxidation of ethanol to acetaldehyde. There are now two carbon-oxygen bonds instead of one in acetaldehyde. However, strong oxidizing agents like potassium dichromate also oxidize aldehydes, so the reaction continues to form a carboxylic acid with 3 carbon-oxygen bonds. In the case of the acetaldehyde we just made through the oxidation of ethanol, it would be oxidized further to acetic acid, which you may recognize as the active ingredients in vinegar. Even without the strong oxidizing agents, bacteria can metabolize alcohol in the presence of oxygen to make vinegar, which can give alcoholic beverages a vinegary taste. So what if you want to oxidize a primary alcohol but stop at the aldehyde stage? PCC and methylene chloride, as mentioned earlier, is not as strong of an oxidizing agent and will not oxidize aldehydes, so it can oxidize primary alcohols and stop at the aldehyde stage. There are other methods of oxidation that do not involve chromium compounds, such as the strong oxidizer sodium hypochlorite, a common ingredient in bleaches, or weaker oxidizers seen with the Des-Martin periiodinane, or DMP reagents, or the Swern oxidation method.